In this video, let us continue our discussion on process synchronization. In the last video, we have seen that the critical session problem is to design a protocol that the process can use to cooperate. This is the general structure of a process having critical session. Each process must request the permission to enter its critical session. The section of the code implementing this request is called the entry session. This is to enforce mutual exclusion. It then executes in the critical session. Once it finishes executing the critical session code, it enters the exit session code. The code that is not part of the critical session is a reminder session. The solutions to the critical session problem can be categorized as hardware solutions, software solutions, and the solutions supported by the operating system. Let us first discuss about the hardware solutions. In a uniprocessor system, concurrency is achieved by the interleaved execution of the process. Only one process executes at a time. The other processes can gain control of the processor through interrupts. So by disabling interrupts, processes can be prevented from being interrupted. Before entering the critical session, the interrupts are disabled, and on leaving, interrupts are enabled. When interrupts are disabled, context switch won't happen. Because of this, the critical session cannot be interrupted. This method is simple, but it has several disadvantages. Disabling interrupts for a long period of time degrades the efficiency of the CPU, not suited for multiprocessor system. Disabling interrupts requires special privileges. User process generally does not have the privilege to disable interrupts. Hence, it is applicable only to the kernel process. Due to the disadvantages mentioned, many systems provide special machine instruction to solve this critical session problem. One special instruction is a test and set instruction. An important property of this instruction is that it executes atomically. That means the function cannot be interrupted in between. The function accepts a Boolean argument, and if the argument is true, it returns true. Otherwise, it sets the target to true and returns false. On systems that support test and set instruction, the mutual exclusion can be implemented by allowing the process to share a Boolean variable, say log, initialized to false. The general structure of the process is given here. While test and set log, this is the entry session, then the critical session, log equal to false is the exit session. Any process that wishes to enter its critical session executes the test and set instruction and passes the value of log as the parameter to it. If the value of log is true, that means some other process is in the critical session. Test and set instruction returns true, thus blocking the process in the while loop. If the value of log is false, means no process is in the critical session. The test and set instruction sets the value of the log to true and returns false. Hence the while loop exit and allows the process to enter its critical session. Since the value of log is set to true, no other process can enter the critical session. On exit from the critical session, the log is reset to false so that the critical session is free for other process to enter. This algorithm satisfies mutual exclusion and progress but does not satisfy bounded waiting. Let us discuss the remaining solutions in the next video.